Okay, hello everyone. Myself Prakyati. I'm working as assistant professor in Department of Electrical and Electronics Engineering. Today I'm going to explain introduction to the servo motors and discussions on servo motor and its applications. So first we are concentrating on AC servo motors. As we all know that the servo motor is a AC motor and also it is obtaining from DC also. So we have both the motors, AC servo motors and DC servo motors. So AC servo motor basically a two-phase servo motor, that is induction motor. A few watts to 100 watts is commonly used in feedback control system. In servo application, an induction motor is required to produce rapid accelerations from standstill. So you can see here we have a servo motor here and the amplifier here, and there is an error detector here and reference input, and there is a control device, and we have a feedback loop over here. So here the servo motor is controlled by an amplifier, and if you have any error in the system, again it is given back to the feedback and to the error detector. So the reference input and the error detector feedback loop is going to uh, compare. If any difference in this, then it is going to detect that as an error and it will give to the amplifier and then it will give to the servo motor. Some constructional features of servo motor is squirrel cage rotor. It is having a squirrel cage rotor with copper or aluminum conductor. So as we all know that, and as I told, this is an two-phase induction motor. So two-phase induction motor, the construction of induction motor, as we all know that it is having a squirrel cage rotor and it is made up of copper or aluminum conductor. High rotor resistance. It is having high rotor resistance and a small diameter to length ratio to minimize inertia. Two stator winding in space quadrature, one called reference winding and other called control winding. As we see in the laboratory, because all of you are going to do this experiment in the laboratory, we have a reference winding and we have a control winding. So the control winding, we are going to apply some voltage. According to that, the reference winding, it is going to calculate how much voltage it is required to energize. So two voltages to the stator winding must derive from same source. So or they must be in a synchronism. So the principle of operation of AC servo motor, the two applied AC voltage to stator with a phase difference produces a rotating flux. Okay, again, yeah, the working principle of AC servo motor, a two applied AC voltage to the stator, that is reference winding and as well as control winding with a phase difference. Because of the phase difference between these two produces a rotating flux. As this moving flux swaps over the rotor conductor, a small EMF is induced in rotor. So the rotor begins short-circuited current will flow, and this current interacts with the rotating magnetic flux to produce a torque in the rotor. So this is a general as induction motor is going to work. Same similar way this motor is also going to work. So this is the block diagram of AC servo motor. And this is very important here, the torque speed characteristic of AC servo motor. For induction motor in high power application, the rotor resistance is low in order to obtain maximum torque. So positive slope part of the characteristic is not suitable to control application as this results in stability. So in AC servo motor, high resistance rotor results in negative torque speed characteristics. This characteristics is needed for positive damping and good stability. The rotor has a small diameter to length ratio to minimize the moment of inertia and to give a good accelerating characteristic. However, more rotor resistance result more losses and less efficiency. So one rotation, see here the winding A will produce like this and winding B will produce like this. There is a difference in phase. Because of this only the torque is going to create in the AC servo motor. Then the transfer function, the torque developed as a function of shaft angular position and control voltage. So G of S is equal to theta S by E naught of S. So that is equal to Km divided by J square plus ds. So d is nothing but a damper, J is nothing but inertia, and Km is a constant. So this is the transfer function we are going to obtain uh, in order to get the torque development in the AC servo motor. Next, we have a merits and demerits of AC servo motor. The merits of AC servo motor is low cost, less weight and inertia, high efficiency, and fewer maintenance requirement is necessary. So demerits of AC servo motor is nonlinear characteristic, used for low power applications, difficult for speed control and positioning. These are all the demerits of AC servo motor. And AC servo motors are important in a control system because we are going to control this type of AC servo motors according to the control winding and as well as reference winding. So this is very important as a point of examination also. And we will moving on to the next concept, the theoretical concept in this control system, that is synchronous pair. So this synchronous pair, we have a transmitter coil and we have a receiver coil. Both the position with respect to angle, it should be same. Then only the transmitter and as well as receiver in a synchronism, in a synchronous receiver and transmitter pair with a synchronism. So if it is not there, then again there is a transmitter and receiver difference is going to happen. So that is not in a synchronism. So here it is also known as self-syn. It is a self-synchronizing device. So it is a self-synchronizing device with the measurement of angular difference between transmitter and as well as receiver. It is going to self-synchronizing with the help of feedback networks, widely used in servo mechanism as a position indicator. So the some of the importance of synchronous system we have. The synchro system with transmitter and control transformer, synchro system with synchro transmitter and motor, synchro system with transmitter and as well as differential and motors. So these are all the three types of important synchro system we have. So the construction, if you go for constructional feature of synchros, we have a transmitter side and we have a receiver side. And the construction of synchro transmitter, motor and transformer are almost the same because all are working on a mutual inductance. Stator laminated with silicon steel, slotted to a house distribution three-phase star connected winding with axis of 1200 apart. Next we have stator not directly connected to the supply. So stator is not directly connected to the supply. Then rotor is having a two pole with single winding connected to AC source. So it has a two pole, in that single winding is connected to AC source. The magnetic field in excited rotor induces voltage in stator coil. So the magnetic field is going to induce voltage in stator coil. The magnitude of voltage induced in any stator coil depends on the angular position. So all the stator and as well as rotor position is mainly dependent on angular position of the coil with respect to rotor axis. Then synchronous control transformer as a cylindrical shape rotor, so that air gap flux is uniformly distributed around the rotor. So this is how the construction of synchro transmitter pair. We have a transmitter like this and we have a receiver like this. So this is the construction of synchronous transmitter pair. Next, we have a synchro transmitter. There is a two part, one is transmitter and another one is receiver. So it is not a three phase machine, it is a single phase machine. Here the input is angular position of its rotor shaft. The output is a set of three stator coil to coil voltage. The common connection between stator and coil is not accessible. Uh, Okay, then the synchro system with synchro transmitter and synchro motor. The rotor of both the synchros device are connected to the same AC source. That is nothing but receiver and as well as transmitter. Both are connected to same source. Using two synchros for maintaining synchronism between two shafts. When rotor windings are excited, EMF are induced by transformer action in the stator winding of transmitter and motor. So this working principle of synchronous is as similar to that of transformer, that is mainly dependent on mutual inductance. According to that, the EMF is induced in a transmitter and as well as receiver. So according to that, this synchro transmitter pair is going to work. Then the synchro system with transmitter, the differential and motor. The function of system is to permit the rotation of shaft to the function of sum or difference of rotations of two other shafts. Okay. The differential has three-phase distributed winding on both stator and rotor. So differential synchro pair having a three-phase distributed windings both on stator and rotor. The voltages impressed on its stator winding induces corresponding voltage in the rotor winding. So this is all about this session.